So hi guys, I'm Aditya VS again, and today we'll be discussing about reduction of a matrix into its row echelon form. So again, we'd be discussing about row echelon form, and I'd be taking the same matrix which I took it in the previous video with the elements as follows, where we see 3 1 2 5, 1 2 minus 1 2, 4 3 1 and 7. We give the code in our MATLAB for representation of a matrix, and we get our matrix capital A as follows. So again, I should basically give you some insight into what row reduced echelon form is, or echelon form is. So basically a matrix is in row echelon form when it satisfies some of the other following conditions. The first non-zero element in each row, called the leading entry, is 1. This is one of the most primary conditions. Each leading entry is in a column to the right of the leading entry in the previous row. Again, this is important. Rows with all zero elements, if any, are below the rows having non-zero elements. So anything of any matrix for satisfying all these three conditions is in its row echelon form or reduced row echelon form. For this particular matrix, I've written down the transformations and we proceed as follows. So we see A, that is our matrix. R1 is R1 divided by 3, where 3 is A1 comma 1. By 1 comma 1, it means the first row and the first column. So after we give that code, we see our matrix has been transformed into 1, 0.33, 0.67, 1.67 and something. Basically, what we have done is we have performed one row transformation. Performing another row transformation, that is R3 equals A3 minus A1 into A3 comma 1. First of all, we should look what 3 comma 1 is. In this matrix, 3 comma 1 is 4. So what we do is we do R3 equals R3 minus 4R1. This is what this code means. Performing further transformations such as R2 equals R2 minus R1. If we want to represent R2 minus R1, where R is our rows, we give it a code where we have our matrix name A with bracket open and the row number, comma and a semicolon and a bracket close equal to A comma A bracket open, row number comma and colon minus A bracket open 1 comma colon. This is the way how we perform transformations on a given matrix. So after we do that, we see we've gotten two zeros in our matrix. That means one is a pivot element and the other element is 1.667. So this is almost an equivalent matrix. We're just bringing it into its form. Now the third one, A 3 comma colon equals A3 comma colon minus A2 comma colon, which means R3 equals R3 minus R2. By doing that, we see our last row is completely zero. The first one's pivot element stands same as 1. The second one still stands at 1.667. Now in our matrix, I really don't want values such as 1.667. I want values like 1. So what do? I need to divide this second row completely by 1.667. So what I do is I do R2 is R2 divided by 1.667. Again, what is 1.667 in this matrix? It is the index number 2 comma 2, where it is the second row and the second column. Second row and the second column. So by doing that, we obtain a matrix which is 1, 0.33, 0.667, 1.6667, 0, 1, minus 1, 0.2, 0, 0, 0, 0. So this, as you've seen, is our row reduced echelon form matrix with with this one and this one as pivot elements, and this is our row reduced form for the given matrix 3 1 2 5 1 2 minus 1 2 4 3 1 7. I'd catch up with you in the next video where we verify that the number of pivots is same as the number of ranks. Thank you.